Okay, this is my Vauxhall Movano 2.5 CDTI 2.5 litre 3.5 tonne van, and it's a 2007 model. I bought it in 2010, turned it into a motorhome, and then decided to have a go at trying to improve its MPG by adding some high octane fuel. And the fuel that I'm adding is LPG. It could be hydrogen, which has a very high octane rating. It goes like rocket fuel, alcohol, petrol even. But LPG has an octane rating of around 113 compared to 90 for petrol to 98 for. So what happens when you add high octane fuel to a diesel engine is it actually increases the octane rating of the diesel. And this has been investigated, and indeed the engine knock, which causes the combustion because it's a compression ignition engine, is reduced, the peak pressure. And it's that reduction in the peak pressure of the engine knocking that improves the combustion efficiency. So it's not about thermal knocks or prompt knocks. This is about a shockwave in the cylinder caused by the engine knock or the detonation of the fuel, and the cavitation of that fuel causing a shockwave which ignites more fuel, and it also unfortunately makes nitrogen combine with oxygen to produce NOx. So what we have is an engine that operates by engine knock causing NOx. So all diesel engines do this, and that's why they should be banned. However, we can reduce the amount of NOx by reducing the peak pressure by adding a high octane fuel with the diesel. So I'm using LPG simply because I've got an LPG tank to do the cooking on. So I trialled this in 2011, and the feasibility showed that it did improve the MPG. So on this van it went from about 36 miles per gallon to about 44 miles per gallon. And I continued to modify the injection system under a lot of testing to find the best and most optimal amount of LPG to add for a given engine speed and engine load. And we've tried this on cars, on a Honda CR-V, on Ford Transit, on various lorries from MAN, DAF, and it works on all diesel engines so far. Every single engine I've put this box on, it's improved the miles per gallon, and it's also decreased the amount of nasty emissions such as engine NOx. So the NOx almost disappears on engine idle, and typically would go down to about 20% in general driving, and the fuel improvements is about 10 or 12%. So that's quite significant for a truck, but the best thing about adding the gas is it improves the combustion and gives more power to the engine and makes it go a bit faster. Okay, so this is the most recent box here that I've installed. It's got a little OLED screen, and this particular box was installed in 2014, and here's an example circuit. As you can see very quickly, it's only a couple of chips, very low cost, and it measures the fuel pressure and the injector on time to within a couple of millionths of a second. So it can work out the diesel fuel flow rate and then instantaneously add the right amount of gas. So I'm going to start the engine up now and just take you through what this box shows. Right, got my pen somewhere. Okay, I'll just zoom in a little bit so you can see what's going on there. So we can see here, it's noted the engine is running, and this little blinking is telling me that the engine is in fact running, and you can hear the running. And this number here says 12.7 degrees. That's the gas temperature entering the engine. And this is my gas pressure, which is a little high at the moment. It normally runs about 1800, and it will be coming down as we run it. Engine speed in RPM, which is here, says about 820 at the moment. And then we have three measurements here. The first one here is the injector time. So you can see it's reading 28 at the moment. That's 28 millionths of a second. So it's measuring the injector time in millionths of a second. The second reading here is the fuel pressure, which is actually quite low at the moment. It's in kilopascals. And then we have a reading here showing the calculated instantaneous diesel fuel flow rate. That's an instantaneous, almost instantaneous measurement of the amount of diesel, and it's simply measured by the fact that we know the injector, diesel injector on time, we know the fuel pressure, so we can do a calculation taking into the temperature into account, and that tells us how much fuel is going diesel wise into the engine. So this instantaneous primary fuel measurement of the diesel fuel flow rate is then used to calculate how much gas to add to the engine. So this is a vapor tank, and it's gaseous, so we have to take into account the pressure of the gas and the temperature of the gas, and this is calculated to a valve, an injection system, which adds LPG. That's around an optimal amount to improve the combustion efficiency and eliminate the NOx and reduce the hydrocarbon parts per million. This has been tested on this van with a portable measuring kit, measuring the exhaust emissions, and we can get the parts per million down quite significantly, and we can get the NOx down to about 80% at engine idle. Unfortunately, when you accelerate, it's not going to change that much. It's still going to produce a lot of engine NOx when the vehicle is accelerated. So that's the box display. This red bar that you see here is the actual gas fueling. There's a little red bar that shows the amount of gas being injected, and this yellow one here, that tells me the fuel that's in the tank. So you can see as I rev the engine up, you can see that red line here increase. Okay, and you can also note that when I release the engine after I've revved it up, this one says off and then it starts running again. You also notice my injection on time. Now this engine is cold at the moment, so the actual injection on time is quite high. That's because the engine's cold and we have a low fuel pressure. But as you can see, as we start driving and the engine warms up, this injection on time will reduce and the fuel pressure will increase with the engine revs. And this is why you have to take an instantaneous reading. You do need a pretty fast reading from the diesel injectors to get this to work so that the right amount of gas is delivered to the engine in the right time. Okay, so go for a little drive and we'll see where we go. Hopefully the vibration of this van, you'll still be able to see what's going on. As I put my foot down, you can see the red line go up, primarily because of the injector on time as we accelerate. The temperature is still 12 degrees and the engine is cold still. So as the engine warms up, you'll see some of those figures change slightly. Downhill now, and you see the injections are off, and now we're going uphill. You can see that they come back on again. Going downhill. Notice that the engine is now off, there's no injection and no gas being injected to the engine. Rather interestingly, you can in fact, with the wind in the wrong direction, the windows open, actually smell the exhaust from this van, and you can smell the gas coming from the exhaust if you're standing outside. So this box has been in operation since 2014, so it's basically 7 years on this van, and this van has done about 80,000 miles with a gas injection system fitted. So the engine is running very, very low. So in fact I'm in third gear, just pulling away in third. And that's one of the interesting things about adding gas to this diesel engine, is that you can run the engine at very, very low revs. It would start stuttering and juddering, this engine, if you didn't have the gas switched on. But with the gas switched on, it actually runs smoother. You can also hear the difference audibly to the engine. When you have the gas injected, the engine sounds less knocking. The knocking sounds as if it's been muffled. And that's exactly what the gas does. It reduces the peak pressure of that compression ignition detonation, the knock. Now, a petrol engine also can knock and produce knocks, but modern petrol engines have better control. They don't knock, because knocking is very bad. It wears away your valves, it wears away the pistons on a petrol engine, and basically a modern electronically controlled petrol engine doesn't knock, and rather interestingly, therefore, it doesn't produce NOx, that poisonous gas. A diesel engine always knocks, so all diesel engines will produce some NOx. This is particularly a problem on buses, although you try and get rid of the NOx by squirting ammonia in the exhausts using AdBlue. Unfortunately, this only works when the exhaust temperature is above 150 degrees. So with a bus stopping at a bus stop, the exhaust isn't at that temperature, so it doesn't work. Not surprising. Also, you can mess about with the injection cycles on an engine and make it so that the emissions are as low as possible, but it effectively detunes the engine considerably by doing that. So what they have been doing, and believe you me, Volkswagen wasn't the only one doing this type of thing. You could get it to produce a powerful engine or a low emissions engine just by having a software switch in the engine control unit. And we all know now about the Volkswagen debacle, but actually this was rather obvious on the information I got from this van and from the cars that I put the gas system on. You could actually see what's going on. So I'll just race this up to the motorway, and you can see right now the engine has warmed up a little bit. We're on 2 bars, still injecting some gas. The gas pressure is 1,700. Have a nice tick over speed. take all the cars. Right. On this vehicle I get about 30 brake horsepower more. It's 120 brake horsepower, but it has been measured close to 150 on this vehicle with the gas injection system. And I rather like that. It gives it a bit of go about it. And improves the emissions and improves the fuel consumption. This van, on thousands and thousands of miles, is doing 43 miles per gallon on diesel. Its best is about 48. Without the gas injection system, it's around 33. The best I've got out of it is 36 without. Now this is the piece of motorway that I spent many days and nights driving for hours and hours and hours up and down this motorway, doing experiments to see whether injecting gas works or not. So it does work, there's no doubt about it, but it's about a 10% to 12% improvement in MPG. It's about 20% improvement in NOx emissions. Right now I'm doing 55, I'm going to speed it up to 80, 70 I mean. You can see my engine revs at 2,100. I'm doing nearly 70 miles an hour. And you can see my fueling is quite low on the red, going at constant speed. The diesel injector timing now is about 18 millionths of a second. Foot down and you can see straight away the injection timing now goes to 38, which is the maximum. Now the gas pressure has come down because now we've got gas flowing through the pipework and it's a vapour tank. So when I take my foot off the accelerator, you can see the gas pressure increasing because there's no gas flow. I have two tanks on this van, one underneath it and one inside it, so there's never been a problem with freezing up of the gas because it's inside the van tank. But in cold conditions you'd have to fit a tank system with a heater and vaporizer. If it's about -5, -10 degrees outside, you need to vaporise the LPG. is not necessary on a vehicle like this or a car. Go. So now you can see, now the engine's warmed up, the injector on time has reduced to 21, now on tick over. You'll also note that the idling speed has reduced from 810 to 780. This is because now the engine is warm and there's slightly different okay. There's quite a bit of vibration on this. I'm coming through the van onto this camera, but it's actually quite a small box, and this is with an OLED display. That's the most expensive part of this box, is actually that OLED display. So actually the box is the one of the cheapest components of this gas injection system. Okay, thank you very much.